Now moving on to section 2.8, which is called subspaces of Rn. The idea of subspaces are a pretty large and important topic in linear algebra. However, in this class, we are not going in the depth of what it is in, say, another linear algebra class. We're only barely touching them and focusing on two particular versions of subspaces. So we'll first, with a quick definition here, a subspace of Rn is a set of vectors that satisfies the following conditions. The first is that you have to have the 0 vector is in your set. We'll call this W here. The second is that whenever you have two vectors that start out in W and you add them together, the result is still in W. And the third is that whenever you have a vector and you multiply it by a number, so the vector has to already be in W, and if you multiply it by a number, then it is still in W. So basically, we have vector spaces that have these operations of adding vectors and scalar multiplication. And subspaces are just going to be things that work well with those operations. In fact, subspaces are examples of vector spaces. So let me do a quick example of a subspace here. Let's take W to be the set of all points x comma y such that y equal to x. So that means in my plane here, this line here is W. That is going to be a subspace, and we can just check it really quickly. The 0, 0 point, that is in W, yes. If you take 2 points that are both in W and you add them up, you get this new point, but we do have that y1 plus y2 is equal to x1 plus x2, because individually the y is equal to the x and the y is equal to x. So then if you add them up, so that tells us that we are still in W. And lastly, if you take a constant times a vector here, you will still have the cy equal to cx, and so that this is in W. So that means this straight line is a subspace of R2. So W is a subspace of R2. On the other hand, if you had the set of all points where y is equal to x plus 1, so you're just going to take this line and you're going to shift it up by 1 unit. This is not a subspace. Now, in fact, it fails all three conditions, but the easiest one to check is the point 0, 0 is not in W. And in general, if you want a set to be a subspace, it has to be very, very agreeable with the vector space. It has to be a straight line or something in that fashion, right? This is called linear algebra. One thing that people would say, it's a linear set. Anyways, this is just some examples of things that work, things that don't work. As I said, we could talk about this for hours, but we will leave it there. And then in the next video, we'll look at the only two specific subspaces that we're going to care about, and that is going to be the column space and the null space of a matrix.